Hello everyone, how are you all doing? Today I'll be explaining to you about nodal analysis, which is a common technique used in electrical engineering to analyze the circuits. So, nodal analysis is a circuit analysis method to find the voltage at different nodes of an electrical circuit. This method focuses on node voltage rather than calculating the current first. So once the node voltage is known, the current in the circuit can easily be calculated using the Ohm's law. Nodal analysis is based on KCL, which is Kirchhoff current law, which states that the total current entering a node must be equal to the total current leaving the node. Before going deeper, let's understand what a node is. A node is a point in a circuit where two or more components are connected together, basically being a junction. In nodal analysis, one of the nodes is selected as the reference node, which is the ground node. The voltage at this node is to be 0 volts. All the other node voltage in the circuit are measured relative to the reference node. From here, we can just apply KCL to form the equations. Now for the solving part. There are several steps involved in this. First, we determine the number of nodes in the circuit. Next, we choose one of the nodes as the reference node. Next, we assign voltage variables to the remaining nodes and label the current directions. After that, we apply KCL at each node except the reference node. Then, using Ohm's law, we can express the current in terms of voltage and resistance. And then finally, we solve the equation to determine the unknown node voltage. So now let's solve an example of this simple circuit using nodal analysis. So now in this circuit we have three resistors. One is 4 ohms, 9 ohms and 6 ohms, and we have two DC power supplies, which is 12 volts and 10 volts. So now let's see how we start. So now first we mark the voltages across the points. So this point will be 8 voltages because of this DC source. Here will be VA, that is the unknown node voltage, which we got to find. And this is 6 volts because of this. So now we can mark the current directions. So I1 goes here, I2 goes here, and I3 goes here. And that using KCL, we can get the equation I3 is equals to I1 plus I2. Now we can mark that equation as equation number 1. Then we go here, and now using Ohm's law, I is equals to V by R, we can get I1, I2 and I3. So here I3 is equals to the voltage drop across this branch, so which is VA minus 0, the whole divided by 6, which is I3. I1 is equals to 8 minus VA, the whole divided by 4. And here will be 6 minus VA, the whole divided by 9. Then we go ahead and put that back into the first equation, and we solve for VA. So in the end, we get VA as 5.052 volts. Then we go back to the voltage drop, which we can find V1. So V1 is this, V2 is this, and V3 is this. So V1 is basically 8 minus VA, which is 8 minus 5.052. V2 6 minus 5.052. And V3 is VA minus 0, which is equals to 5.052 itself. Now, after we got the V1, V2, V3, we can finally get I1, I2, and I3 using the Ohm's law. I is equals to V by R. We put V here, and R is the resistor here. So, in conclusion, nodal analysis is an effective and widely used method for analyzing electrical circuits. By selecting a reference node and applying KCL, we can form equations that allow us to determine node voltages in the circuit. Once the node voltage is known, other quantities such as current and power can also be calculated. Because of how simple and effective this is, nodal analysis is an important technique used in electrical engineering. So yeah, that's it for now. Thank you for listening to me and have a blessed day ahead.